All right, let's jump right into one of the biggest, most mind-bending questions in all of physics. It's a rule we all kind of know, right? Nothing goes faster than light. But the reason why that rule exists, well, that's where things get really interesting. So, why can't we? I mean, it seems like it should just be an engineering problem. Just build a bigger, better engine and boom, you're there. But the real answer has absolutely nothing to do with technology. See, the universe isn't just handing out speeding tickets. It's literally protecting its own sanity. And this right here is the key. You have to stop thinking of it as a limit on speed and start thinking of it as a limit on logic itself. The speed of light isn't a goalpost. It's the universe's ultimate firewall against reality breaking down. So here's how we're going to unravel this. We'll start with this idea of a limit on reality. Then we'll see how that connects to spacetime. We'll look at the insane energy barrier the universe puts up, and then dive into a wild quantum insight from Richard Feynman before we finally get to the real speed limit and what might lie beyond it. Okay, so first things first, we have to completely reframe the question. Forget about rockets and spaceships for a minute. Just think about the fundamental operating system of the cosmos. That's what's actually being protected here. It's all about keeping the rules of the game consistent. Our first huge clue comes from, you guessed it, Einstein. He showed us that space and time aren't two separate things. They're actually woven together into the single four-dimensional fabric we call spacetime. And if you try to punch through the speed limit on that fabric, you don't just tear a hole in it, you completely shred the very idea of a timeline. And that brings us to the single most important non-negotiable rule in the entire universe, causality. You flip a switch, then the light comes on. You drop a glass, then it shatters. Cause always comes before effect. If you break this rule, reality just stops making any sense at all. And this is where it gets crazy. Because space and time are so deeply linked, going faster than light is basically the same thing as going backward in time. Just think about it. If you could send a message faster than light, you could get a reply to your message before you even sent it. Effects would start happening before their causes. And the universe just cannot allow that kind of paradox to exist. So you see, it's not really a speed limit at all. It's a cause and effects limit. It's the universe's way of making sure that the cosmic story always makes sense, that one chapter always follows the last. So, if the universe absolutely has to protect causality, how does it actually stop us? Well, it doesn't just put up a cosmic stop sign. No, it builds a wall made of pure, raw energy. Here's how it works. The faster you push something with mass, the more inertia it gains. Basically, the harder it becomes to push. It's like reality itself starts pushing back against you. At first, it's easy. But the closer and closer you get to the speed of light, the universe pushes back harder and harder, demanding an absolutely ridiculous amount of energy for every tiny increase in speed. And right there, that's the wall. To actually reach the speed of light, any object with mass would require an infinite amount of energy. Not a huge amount, not an unbelievable amount, a literally impossible amount. Infinite. The game just stops. And that's the beautiful part. This isn't a problem we can just solve with better technology. The universe hard-coded this energy barrier right into the fabric of space-time, all to protect its own logical rules. But believe it or not, the story gets even weirder and more profound when we zoom all the way down into the quantum world. The physicist Richard Feynman gave us this incredible peek behind the curtain, showing us how reality works at its most basic level. Turns out, the universe is constantly trying out possibilities, even ones that seem to break the rules. In our world, you throw a ball and it follows one single path, from your hand to its target. Simple. But down in the quantum realm, a particle, like an electron, doesn't just take one path from point A to point B. No, it takes every single possible path, all at the same time. And here is the absolute mind melter. Among those trillions of paths are some that actually seem to go faster than light. It's like reality is constantly testing its own limits. But Feynman figured out that for every impossible, rule-breaking path, there's another that's its exact opposite, and they just cancel each other out. The only paths that are left, the ones that survive to create the reality we see, are the ones that play by the rules and respect the speed limit. Okay, so now we can finally put all the pieces together. The logic of causality, that infinite energy wall, and this bizarre self-correcting quantum dance to see what this universal speed limit really is. So the biggest takeaway here is that you can't move faster than light, but that's just a symptom. That's not the actual rule. The real rule is so much deeper. This is it. The real speed limit of the universe is the speed of information. It's the maximum speed at which any cause can create an effect. It's the speed at which one part of the universe can know about another. So maybe we should stop calling it the speed of light and start calling it what it really is, the speed of causality. It's the universe's ultimate processing speed. It's how fast reality itself can happen. And light, why is it the poster child for this whole thing? It's simply because photons, the particles of light, have zero mass. They aren't held back by that infinite energy wall, so they're free to travel at the absolute maximum speed the universe allows. Light isn't setting the limit, it's just the most obvious thing traveling at the limit. It's the passenger, not the driver. But understanding this deep rule doesn't just tell us what we can't do. It actually inspires physicists to think about some really creative ways to work with the rules instead of trying to break them. So when you hear about crazy ideas like warp drives or wormholes, they're not really about breaking the speed of information. Not at all. They're about finding loopholes. A warp drive wouldn't move through space faster than light. It would work by bending and warping space itself around the ship. You're just changing the journey, not your speed. So in the end, this universal speed limit isn't some frustrating wall holding us back. It's a guidepost. It's one of the most fundamental clues we have about the nature of reality, of causality, and of information itself. And that forces us to ask the best question of all: where is it telling us to look next?